Hey guys, welcome back. Let's take a look at ions. First, we have positives, and these are called cations. Second, we have negatives, and these are called anions. First, let's look at cations. For an example, we're going to use sodium. Two rules that we're going to work with here are the electron configuration and, secondly, the octet rule. The octet rule says that everything wants to have 8, with the exception of hydrogen and helium, which only go to 2. So the electron configuration for sodium is 1s2, 2s2, 2p6, 3s1. To get to 8, sodium would have to get 7 electrons. This is very difficult. But if sodium loses 1 electron, it can get to a ground state of 8, which would be like the configuration of neon. 1s2, 2s2, 2p6. Now, if it loses 1 electron, it will become +1, and now it has 8 in its valence. A similar thing can happen to magnesium, which is right next to it. Magnesium starts out as 1s2, 2s2, 2p6, 3s2. Now, instead of getting 6 more electrons, magnesium is going to lose 2. This way, it will go down to a ground state that has 8 in the valence and will be more stable. Therefore, magnesium will have 2 pluses because it lost 2 electrons. This is true for the whole group. Group 1 will all be +1. They will all lose their s1 electrons. And group 2 will all lose their s2 electrons, making them +2. For an example of an anion, we will look at the group 17, which is halogens. Let's take a look at fluorine. Fluorine has an electron configuration of 1s2, 2s2, 2p5. This means that fluorine is 1 away from being completely filled. So it's easy for fluorine to take that extra electron. So fluorine will take the extra electron, and it will become filled just like the noble gas next to it, and will have a negative charge because it gained an electron. This is true for the entire group. Group 17 are all -1 charge. So these principles hold true for the majority of the elements as they have charges on the periodic table. Thank you. See you again next time. Bye-bye.